Hello friends, this is Alvin, and in the last video there was a complaint about the question not being clear, so I have written it a little bigger. And the question is like this: that object is moving with a uniform velocity, and how much force is acting on that object. If an object is moving with uniform velocity, then the amount of force acting on the object is how much? It's a very simple question, but we have to understand the statements or laws of motion for this. So whenever you approach this problem, you have to think about whatever the things that we know for sure. So, and we are going to get the answer for that. So I would like you all to attempt this problem from the statements that you know. So despite of the problems being unclear, Albert Francis, one of my Facebook friends, he has answered this question very correctly, that he has taken the help of Newton's second law of motion. Second law of motion states that force is the product of mass and acceleration. That is a mathematical law, statement of force. So if an object is moving with uniform velocity, then the acceleration is zero, because there is no acceleration, because the acceleration means the velocity keep on changing. So if the velocity is changing, there is acceleration. So velocity is uniform, that means there is no change in velocity, that means the acceleration is zero. So if acceleration is zero, that means the force acting on the object is zero. So that is one case. But as we know that force is equal to, as I can write it down, and force is equal to mass into acceleration. Force, it is equal to mass into acceleration, or if it is not clear, I can write it down here. It is force, it is equal to mass into acceleration. Fair enough. If the force is if the acceleration is zero, then mass into zero, it is going to give you the force, it is equal to zero acting on that object. But what if the mass is changing? That is, for example, if I blow a balloon and if I leave it, so that means the air inside the balloon is coming out, that is mass of the object is in, it is changing. So even if the velocity is constant and mass is changing, so it is going to be, the acceleration is zero, and if there is a change in mass, if the mass is changing, right, so is the force acting on the object zero? That is what we need to understand. For that we have to make a derivative of this. That is, we can find out that force is equal to rate of change of momentum. It is m dv upon dt, or you can write it dmv upon dt. So that is rate of change of momentum. The force, it is equal to a rate of change of momentum. Alright, so this is one example that I'm going to give. And force, if we think it in terms of rate of change of momentum, you can make it like this. This is a product rule. It will be m into dv upon dt plus v into dm upon dt. Now what is m into dv upon dt? Dv upon dt is nothing but acceleration. So we know that the object is moving with uniform velocity, so it is zero, rate of change of velocity is zero, plus v into dm upon dt. Now in this problem, anywhere I have not mentioned that mass of the object is same. So mass of the object can keep on changing with time. So dm upon dt is a quantity with change, which gives you an idea about the rate of change of mass with respect to time. So if the mass is changing with respect to time, then even if the velocity is constant, that the acceleration is zero, this is zero, so it will be v into dm upon dt. So force acting on the object depends on velocity multiplied by rate of change of mass. So that is, if the mass of an object while moving is changing and it is maintaining the same velocity, then too force is acting. The force is acting when the mass is changing and the velocity is same, and if the mass is not changing and velocity is constant, the force acting on the object is zero. So As you can see from this, that we are using the statement of second law of second law of motion of Newton, and we are going to put it to analyze whether an object which is moving with the velocity v, or a constant velocity, is it going to require any force to move. So there is a possibility here. See the statement here. We have come across with two statements from this. That is, one statement is, if the velocity of an object is uniform, there is no force acting on the object. If the velocity, if the mass of the object is not changing. If the mass of the object is changing, its velocity, even if its velocity is constant, there is a force required to maintain that velocity v. For example, if an object is moving in my hands and it is getting heavier and heavier, to keep its velocity 10 meters per second, suppose, maintain the same velocity, I have to apply force, because it is getting heavier and more force is required to maintain the same motion. Even if the velocity is constant, the velocity is I'm being interrupted by the external sound, but even if the velocity is constant, the force is required to maintain that motion. Now from these two statements, we can find out logically. See here, the logic is like this. See, it is statement after statement. Now see here, first true statement that we have derived is that if the body is in motion, uniform motion, no force is acting on it. But if the body is in uniform motion and its mass is changing, you require a force to maintain the same velocity, the uniform velocity. That is one. So now moving on to the second part, what does it imply? Consider on the first statement. The first statement that we have derived is that no force is required to for an object which is moving at velocity v. The velocity, if something is moving with velocity v, okay, and no force is acting on it, it means that no force is required to move an object through some distance. For example, if you have a motorbike and it is moving with 100 meters per second, so 100 kilometers per hour, suppose. So how much force is acting on it? Since your velocity is not changing, there is no force acting on you. You are just moving without force, which you might see, you might say that it is absurd, because energy is required to move an object, so force is required to move an object. You are just overcoming the frictional force between tire and your vehicle. Okay, you are just overcoming it. You are just producing an equal and opposite force. So net force acting on you is actually zero, and you are moving with the same velocity. So the force acting on you is zero because of friction. You are just overcoming the friction, and you are moving with 100 kilometers per hour. So that means force is not required to maintain any kind of motion. Suppose you are in space, and if this object is moving with 1,000 kilometers per hour, but it is moving with the same speed, it doesn't mean that force is acting on it. Force is actually not acting on this object, and without force this object is moving with 100,000 or maybe 10,000 kilometers per hour. So this is what challenges our logic, because when we think about laws of motion, we will get some results which will challenge our logic, and I hope students will realize that it is fun if your logic is being challenged. You have to think in such a way that we will get an idea about what, how, and why this nature is operating in certain ways. So this is what the purpose of science is, folks. And when you are in science, you have to think about things very logically, and even if it challenges your logic, you have to think through it. There might be some way in which you can make these things understandable. So we are going to take a next section, that is the laws of motion, and we are going to think about it in a very precise way in how to do it. In the meantime, I'm going to leave you with one more problem, and see whether this this objective of ours to reach to statements after statements is going to be successful or not. First attempt was a little shaky, I admit it, but now I'm going to go write one more problem over here, and let's see whether how many comments I get. First comment was correct, and it was given by Albert, and congratulations, Albert, and I think you will support me more on this conquest. And see here, the question is like this. Now an object moves from point A to point B, and this is point A and this is point B. The distance between these 2 points is infinite. The distance between these 2 points is infinite, right? So object moves from point A to point B. It covers infinite distance, and what is the work done? One hint for people who don't know what work is. Work, it is equal to force into displacement. Here the displacement is infinite, so how much work is done? Thank you very much.